Okay, anybody have an answer or something they think might work? 61. So let's see, this is figure 15, 61. Okay, anybody else have an answer? The same or different? What do you think, Isaiah? Did you get anything? No? All right, Colton?
I said 61.
You said 61 also. Okay. Amani, anything? No? How about Noelia? No? Janetta? 61. Okay. Dariana, right? Dariana. Anything? This looks like Greek, doesn't it? You're like, what does this have to do? Gabe, anything? Anybody else over here? Caitlin, Shemaya, anything? Those of you that got 61, can you help explain for the rest of us?
Well, you know how the first figure, the first figure is 5. So if you just add 4 more boxes in the corner, that would be 9. You just have to keep adding 4.
You keep adding 4. Okay. So you said each one has 5. So the first figure has 5. You said the second figure has 5 plus 4, right? The third one you said has 5 plus.
Like, and then that one, it would be like 5, like another. No, that would be like 5 plus. That would be more like.
You're right.
Like
5 plus. Did you say 5 plus 8 or did you say 5 plus 4 times 2? There's
either way it works.
You're right. I'm just wondering how you did it. Or you just added 4 each time?
Yeah.
Okay.
Each time.
Okay. Who else? Janetta, you said you had 61. Did you use that same way? No. What did you come up with? Added 4 12 times. So say a little bit more about that, because you're right. So you said figure 1 has, that's too skinny, I can't see. Okay, so you said figure 1 has number of squares is going to be 5. Figure 2, you said, okay, 4 in the corners. Figure 3, so kind of what Rachel was doing then, right? Okay, all right. And did you just say plus 4 and you kept track of each one? Like you did 4 and 5 and 6 and you did every single one. Is there a way I can figure out how many 4s without finding all the previous problems? You know what I'm saying? Without having to go in order. Because that's a little tedious, right? Right? Not terribly, but. So how does the number of 4s compare to the figure number? So this would be 5 plus 4 plus 4 plus 4. How does the number of 4s compare to the figure number? Guys, I need you all looking up here. Yes! It is always 1 less than the figure number. So if I had figure number 6, it's 5 plus 4 times 1 less than that. which is going to be 5. So there would be 5 plus 20 is 25. So if I do figure 15, that's going to be 5 plus 4. 1 less than 15 is 14. And you get 5 plus, what is that? 56, which is 61. Okay? Great. Now, there was a third person who said they also got 61. Who was that? Colton. Did you use that same method?
No.
Good, good. Tell me what, and it might not even be the method I'm thinking of. Tell me what you did.
The number that, like, for group 1 has 1 box going out, and then group 2 has 2. So for 15, I did 15 times 4, and then plus 1.
Oh, yes. So excellent. I am so glad you brought that up. So this is another method to find this. Okay. Instead of looking at as 5, 5, and adding 4, what if you look at it as a single 1 in the center plus, in this case, 1 plus, you said 4 times 1? 1 times 4. 1 times the 4 corners, right? Is that what you said?
I think so.
I think so too. Maybe not though. So this would be the 1 in the center plus you have 2 right here, 1, 2 in each corner for each of the 4 corners. So that would be 2 times 4. And here, that 2 is actually the same as the figure number. So this one would be 1 plus, here you have 3 times each of your 4 corners. So 3 times 4, which is 13. So if I do figure 15, it is 1 plus 15 times 4. 15 times 4 is 60 plus 1. Isn't that cool? Yeah, it's fine. It's fine. But you can do it by way of just that 1 plus adding the 4 in each of the corners, or you can look at it as a pattern of 5 plus adding on to the corners. Okay? All right. Good job. Any questions about this visual pattern? Okay. So now let's open up your books to page 61. We are going to be comparing expressions. Page 61. Page 61. And we are talking about a college university with male and female students. All right? We are a little bit behind because you guys had that class senior talk the one day, and so that skipped this class. But we'll try to get through as much as we can. All right, so follow along, pay attention on page 61. Let X and Y denote the number of male and female students respectively. So respectively, that means males are going to be X number and females are going to be Y number. This is on a college campus. And X is less than Y. X is less than Y. If possible, determine which of the expressions is larger. Interpret each of the expressions in terms of populations. Okay? So, I'm going to write mine down like yours are, kind of sideways. So we have X plus Y. What does that represent if I say X plus Y in the population? So that is what? If it's male plus female, it is, what's another way of saying males plus females? Yeah, but I'm talking about in terms of this problem. Say it again. It's not just males, though. It's males plus females, which is students. Yeah, all students, right, of the university. So X plus Y is all the students at the university. Okay. And how does that compare with 2Y? And what does 2Y represent out of this word problem, story problem? What does this represent? Two what? Two female. Yeah, but what is Y again? Female. So if I say 2Y, I'm talking about double what? Yeah, double the female population at the university, right? Double the female population at the university. Okay, so if I was comparing all the number of students and comparing that to double the number of female students, which would be larger? Is it the first expression, x plus y, or the second, 2y? Which one? The first one.
It's talking about all the students and not the only the female ones.
Well, all the students, yes. Comparing that to 2y. What do you guys think about that? Morgan says no. A little bit louder. Yeah, x is less than y. So x is the number of males. We have fewer males, right?
I know, but it's all students.
Right.
So wouldn't that be like adding males to females? So
it is all the males plus all the females.
If there's less male and there's a lot of females, if you add them together, it kind of be a little bit more.
It would maybe seem like that, but let me show you something. So we can actually, were you going to say something? Okay. Where's your other class? L hallway. Can you just grab one from here? And when we have kind of a downtime, I'll let you go. That be okay? They're over here in this spot. So let's take a look at this algebraically. You're like, oh, great. So let's say x plus y, let's say we're trying to see if it's equal, which we know it probably is not. If I were to try to solve this for something, what could I do to start solving here? Subtract what?
Y.
Subtract a y. So if I take away a y here, and I take away a y here, I'm left with x, and I'm left with not 2, because this y is actually 1y, right? So 2y minus 1y leaves me with y, and what do we know about x compared to y? It's less than. So if you take away the same amount, isn't x plus y still going to be less than 2y? Because if this is true and I add y to it, it's going to be less than. Yes?
It's always going to be less than 1.
Yes, that's right here. They gave us that. Did you see that? Yeah, so x is always less than y. And if I add the same amount back to it, then x plus that y is going to be less than twice that y. All right? Does that make sense? A little bit? Okay. Sometimes I need you guys to like nod your head this way or this way. That way I know you're actively engaged, okay? All right, let's take a look at the second one. I have x divided by x plus y, And what might that represent?
Divided into males and females.
Males divided by what?
Males divided by females.
Okay, so I'm going to say it's a fraction of the males out of the whole population, right? Fraction of the males out of the whole population. And then we're comparing that to y over x plus y. What does that represent?
Fraction of females in the whole population.
Okay. A fraction of the females out of the whole population. I don't think that's a good use. Okay. So, which is going to be larger in this case? The first, x over x plus y, or the second, y divided by x plus y? Okay, why? X plus y is the same for both, right?
No, I meant x less than y.
Okay, and why is that? Yeah. So if you have a larger number on top of your fraction, comparing it to a smaller number, the fraction with the larger denominator or larger numerator is going to be more. Okay? All right, any questions about that? Okay, let's look at the next two. Oh, not next two, next one. Here I have x minus y divided by 2. We got to figure out what that represents in the population, and we're comparing it to x divided by x plus y. X minus y divided by 2. Whole students? I don't think it's whole students. What is x again? Males. So males minus females. Number of male students minus the females. And then we're going to divide it by 2. So there's not a really good way to say this with words. It's just the number of males, excuse me, minus the number of females divided by 2. All right. What about the second one? What does that represent? Yeah, fraction of males out of the entire population. That's the same as one we just did. Fraction of males out of the whole student body. Well, it's a campus. It's in a university. So we're talking about the number of females and males on a college campus. So now that we kind of know what we're talking about, which of these expressions is going to be larger and why? Why? Can't just guess. I mean, it could have been a guess, right?
Like, wouldn't like the x in the denominator is x plus y, and like the numerator is like x minus y. Like, there's subtraction in the first problem.
There is subtraction in the first expression.
And the second expression has the addition instead of subtraction. So.
Well, but the addition is in the denominator. So you can't really compare those. I see what you're saying, but they're not comparing the same things. Gabe. Put on your thinking caps. Anybody have an idea on this at all? What kind of number do we get
2.
for x divided by x plus y?
Oh,
Say it again?
just 1.
No. Did you say 1 or y? Y. No. If we get x divided by x plus y, what kind of number are we getting there?
1.
A positive number. Okay. Can you say a little bit more? What kind of a positive number? Is it a whole number? Is it... No, it's not a whole number. A decimal. It's a fraction, right? It's positive and it's a fraction. That's the kind of number we're talking about. What about in the top or the first expression? Males minus females divided by 2. Negative? How'd you get a negative number?
Because isn't like males are less than females?
Yeah.
So if you subtract a male and a female, it will be a negative.
Yeah, a negative value divided by 2. So when you compare a negative value to a positive value, the positive value is always going to be larger, right? You're like, oh, yeah. Does everybody see that? Does anybody want to see that? Yeah, there we go. Any questions on university population? Okay. Let's turn and let's do some independent practice. Oh, no. Only I'm not going to let it be totally independent. So the directions say for each pair of expressions, without substituting in specific numbers, determine which is larger. So 5 plus t squared or 3 minus t squared, which would be larger, and try to jot down a phrase or two why you think. So I want you to either do it by yourself if you want to. I want you to, if you want to, use or talk to a partner near you. Okay? Just so we can get some thinking going on here. I'm going to give you about 4 minutes total. So till 10:25. Okay? Look. If I am looking at 5 plus t squared and 3 minus t squared, Chris, which one of those is going to be bigger? Okay, and why? As opposed to subtracting. Yeah, because 5 is greater than 3, and your 5 plus your adding is going to be greater than 3 subtracting something behind it, right?
I just say 5 is bigger than 3 and have plus sign and have negative sign.
Yes, exactly. These are your notes, so anything that's similar to that, just so you have an understanding of it. Any question about that one? Okay, good answer, Chris. I appreciate that. All right, let's take a look at the next one. So 15 divided by x squared plus 6 and 15 divided by x squared plus 7. Isaiah, what do you think?
I think 15 and x squared plus 7 is greater than 15 x squared plus 6.
Okay, so like this. Why?
Because besides that both are addition, 7 is more than 6.
That is true. That is true. So this on the bottom, I would say, is definitely bigger. I hate it when that happens. Bigger than this on the bottom. So this one is smaller and this one is bigger. Does everybody agree with that sign?
Yes.
Yes? Closed case? Javion, what do you think? What is this? No, you don't know? No, you don't agree? No comment. Oh, that wasn't one of the choices. Question. Let's say we are talking about different size candy bars here. If I put 15 over a larger number, 100, and 15 out of, let's say, 20, which is a smaller number, if you like the candy bar, which of these parts of the candy bar would you rather have? 15/20ths or 1500ths? Yeah. So because the first and top number is the same, the smaller number on the bottom is going to give you a larger part of the whole candy bar. So it's actually going to go this way, right? So think of it that way. Yeah, you'd rather have 15/20ths of the candy bar that you like, which is a bigger fractional part than 1500ths, right? Yes.
I divided it, and the 15/20 is 0.75, and the 1500.
Well, not dividing. We're not subtracting. That's dividing. Wouldn't you have 15 parts out of 100 or 20 than 15 out of 100?
I divided and I subtracted.
Okay. It should be the first one is greater than. Okay?
No.
Yes. All right, let's go to the third one. Quantity s squared plus 2 times quantity s squared plus 1. How does that compare with quantity s squared plus 4 times quantity s squared plus 3? Huh? Second one, what?
S squared plus 4 times s squared plus 3
Is
greater than
this, like this?
Yeah.
What do you guys think? Is that true? You don't know anything anymore, right? Because I keep like, ah. Yes, that is true. Because these are all s squares. Those are all the same amounts. And if you multiply a number that is 4 and 3 more rather than 1 and 2, then that's going to be true. Okay? Yes. So this first one is less than this one. What about this last one? 8 divided by k squared plus 2 and k squared plus 2. Yes? Less than. How did you come up with that? First one would give you a decimal. Not always, but a lot of the time, yes. So if I let k be equal to 0, then over here I get 8 divided by 2 squared plus 2, which is 8 divided by 6. If I let k be equal to 0 over here, I get 2. Is 8 6 or 2 bigger? Did I do that right? 2 squared plus 2, right?
No. Wait, you said k is 0, so it would be 0 on times square plus 2.
Oh, 0, not 2. Duh. So this one is actually 8 divided by 2, which is 4. So which one is bigger in that case? This side is bigger, but let's go to 1. If I say 8 divided by 1 squared, which is 1 plus 2, I get 8/3. Over here, I get 3. Which one is larger, 8/3 or 3? 3 is larger. Whoops. And if I do k equals 2,
So it really doesn't matter?
It does matter a little bit. 2 squared plus 2 gives me 8/6. Over here, if k is equal to 2, I get 6. 6 is larger. So the higher your k value number is,
So it will be K.
so most of the time it is like this, except when k is equal to 0. So except when k is equal to 0, then the first side is going to be less than. So that was kind of a tricky one. Okay? All right, questions on expressions. Did you ever think expressions could be so crazy to try and figure out? All right, so now you should be able to begin working on homework. This is Module 1, Number 2. Remember, all the homework assignments have to be done by the last day of the test, and that test, I think, is August 22nd. It is on Canvas. All homework is on Canvas.
Oh, these guys say I thought the homework was just on the paper.
I'm sorry?
I thought the homework was on paper.
No,